Hybridization is a concept that explains the tetravalency of carbon atom. It explains how chemical bonding occurs in organic compounds. As organic compounds undergo a chemical reaction, the hybridization also undergoes a change. It changes from one state into another. There are different types of hybridization. Normally, the kind of hybridization that we encounter in organic chemistry is this, the Sp3 hybridization. It can be written like this: 1s3p, Sp2 hybridization, 1s2p, and Sp hybridization, 1s plus 1p. We are going to discuss each type in a little detail. So we have the Sp3 hybridization here. Sp3 hybridization occurs when one s atomic orbital and 3p atomic orbitals from carbon atom mix together to form 4 Sp3 hybridized orbitals. We have already discussed this in a little detail. Here we have the Sp3 hybridization. 1s and 3p orbitals of the carbon atoms are going to mix with each other to give rise to 4 degenerate hybridized orbital, the Sp3 hybridized orbitals. Each Sp3 hybridized orbital has 25% s character and 75% p character. The 4 Sp3 atomic orbitals are directed toward the corners of a tetrahedron pointed at an angle of 109.28 degrees. Alright, so they are pointed at an angle of 109.28 degrees. This is how these orbitals arrange themselves around the carbon atom. They will arrange themselves in the form of a tetrahedron. Each orbital will align itself along the corner of the tetrahedron. These orbitals will lie at an angle of 109.28 degrees. Each Sp3 hybridized orbital will have a head-on overlap with the atomic orbital of another atom. Just like here in the formation of methane, each Sp3 hybridized orbital will have a head-on overlap with another orbital, with the orbital of another atom. For example, if this is an Sp3 hybridized orbital, it will have a head-on overlap with the s orbital of hydrogen atom. In the formation of methane, 4 hydrogen atoms will come close to the Sp3 hybridized orbitals of carbon atom, and they will form a sigma bond, which is represented by this symbol. A sigma bond is the type of covalent bond which is formed by the head-on overlap between 2 atomic orbitals. Just like here, these orbitals are colliding or touching each other head-on. The next type of hybridization is the Sp2 hybridization. In Sp2 hybridization, 1s atomic orbital and 2p atomic orbitals from carbon atom mix together to form 3 Sp2 hybridized orbitals. The Sp2 hybridization is a little different from the Sp3 hybridization. It can be shown with the help of a diagram. This diagram shows how Sp2 hybridization occurs. So this is the electronic configuration of carbon atom in ground state. What happens is the promotion of an electron from this 2s orbital into the 2pz orbital. The 2pz orbital lies vacant or empty before the promotion in the ground state. But after the promotion or excitation of the electron, this one electron from the 2s orbital will get promoted into the 2pz orbital. So it looks like this. Now you have the 2s orbital and the 2p orbitals. All these orbitals have got one unpaired electron. These orbitals are ready to get hybridized. There is very little energy difference. The p orbitals are slightly above the 2s orbitals, so there is a very little energy difference, and these orbitals can mix with each other and they can hybridize. Now in this step, these unhybridized orbitals containing unpaired electron will mix with each other. One 2s orbital and two 2px orbitals are going to mix with each other, leaving the 2pz orbital, alone. So you will have three Sp2 hybridized orbitals and one 2pz unhybridized orbital. Now the carbon atom will have two kinds of orbitals. Three Sp2 hybridized orbitals. Let me show it here. Carbon atom will have two kinds of orbitals. It will have an unhybridized 2pz orbital which has got only one electron, and it will have Sp2 hybridized orbitals, each containing one electron. This is Sp2, this is Sp2, and this is Sp2. Each has got one unpaired electron. Now these orbitals will arrange themselves along the corners of a triangle. They will arrange themselves at an angle of 120 degrees. Each Sp2 hybridized orbital has 33% s character and 67% p character. The Sp2 hybridized orbitals point toward the end of a triangle or toward the corner of a triangle at 120 degrees angle. Each Sp2 orbital will have a head-on overlap with the atomic orbital of another atom, resulting in a sigma bond. These hybridized orbital will have head-on overlap with the s orbital of hydrogen atom, for example. They will have head-on overlap, just like this, head-on overlap. But this unhybridized orbital, this cannot have a head-on overlap. So it is going to have a parallel overlap. This head-on overlap of the two Sp2 orbitals with the orbitals of other atoms will give rise to sigma bonds. It will result in sigma bond formation. The unhybridized p orbital will have sidewise or parallel overlap with another atom, resulting in a pi bond. When two orbitals come close to each other and they have a parallel overlap, it's not a direct head-on overlap, it is a parallel overlap. Only their sides overlap with each other. This kind of bond is called a pi bond. It is represented by the symbol pi. This is how the formation of ethene occurs. Each carbon atom is sp2 hybridized. It has got 3 sp2 hybridized orbitals. These orbitals are arranged at an angle of 120 degrees. Each sp2 hybridized orbital is overlapping with the s orbital of hydrogen atom in head-on manner. This results in the formation of sigma bond. Sigma bond. Each carbon atom has got an unhybridized p orbital. These p orbitals cannot have a head-on overlap, so what happens is represented like this. These are the unhybridized orbitals. They cannot have a head-on overlap, so only their sides are going to overlap with each other, just like that. Only their sides will overlap. This kind of bond is called a pi bond. Sp hybridization. Sp hybridization occurs when one s atomic orbital from carbon atom and one p atomic orbital from carbon atom mix together to form two sp hybridized orbitals. Each sp hybridized orbital has 50% s and 50% p character. The two sp hybridized orbitals are oriented at an angle of 180 degrees to each other. Each sp hybridized orbital form one sigma bond, and the remaining two unhybridized p orbitals form pi bonds. This is how it happens. These two are the hybridized sp orbitals, and these two, this one and that one, these are the unhybridized 2py and 2pz orbitals. These orbitals lie at an angle of 90 degrees to each other. They're perpendicular to each other. The only way for these orbitals to come close and overlap is to have this parallel overlap. As a result of the parallel overlap between the unhybridized orbitals, we have a pi bond. So in the molecule of ethane, there is two pi bonds and one sigma bond. It can also be shown like this. This is how the concept of hybridization explains the tetravalency of carbon atom, the geometry of different organic compounds, their chemical reactions, their properties, and so many things. So hybridization is a very useful concept, and without having a clear understanding of hybridization, one cannot simply understand how organic compounds are formed and how organic reactions proceed, and how they cannot explain the properties of organic compounds without invoking the concept of hybridization. So I think this much is enough at our level. In higher classes, you can study hybridization and other theories in more detail. So thank you very much.